Hi, and this is question 10 of the Leave It Start Order Level Paper 1 in 2021. As always, if you want to copy the notes I'm using, send me an email at shanetroy@gmail.com. And if you like these videos, hit the subscribe button to get access to more playlists. So question 10 is the last question of this paper, and it's actually quite hard, in my opinion. Part A says the water behind a dam is normally released at a rate of 250,000 litres per second. So let's write that down. 250,000 litres per second. Find how long it takes to release 1 million cubic meters of water. Now, there's a distinction here. This is meters cubed, this is liters. And they tell me, okay, I'll put down here, 1 meter cubed is equal to 1,000 liters. Now, the first thing I need to do is get these all in the same units. This is in meters cubed. I want to find out how many liters is equivalent to that, because I'm trying to find out the time. So the only information I have about flow rate is in liters per second. So I want everything in liters, basically. So if I could use my statement down here. Okay, 1 meter cubed is equal to 1,000 liters. Now, what's a million meters cubed? So I can multiply, okay, both sides by a million. So 1 by a million is a million. 3 6 zeros. So a million meters cubed is equal to, if I multiply this by a million, I have to multiply this by a million. I'm just adding on zeros. So 3 zeros, 3 more, and 3 more. 1,000 million is a billion. So a billion liters is equal to 100,000 meters cubed. Now I could express that in so 1 by 10 to the 9 liters if I wanted to express that in scientific notation. Because again, there's lots of zeros, very easy to make a mistake and forget them. Now I then know that every second this massive amount of water is released. So it's gushing out. How many of them are passed out every second? Okay. So basically I'm asking how many 250,000s are there in a billion? Okay, so that's my liters. Divide that by 250,000. What's that answer? How many of them in this? Now straight away, 3 zeros top and bottom cancel. Okay, I could go ahead and do one more, and I end up with that's 100,000 over 25. Now I probably should just use the calculator. And I have the answer, I think, on the next page, which is, let's check it. Oh, it's 4,000 seconds. Okay. Now, that seems legit, except it says give your answer correct to the nearest minute. Now, if you want to find out how many minutes are equal to 4,000 seconds, and basically, I'll do it down here, 4,000, how many 60s in 4,000? Now, that's a calculation that gives me an answer of 66.67. Now, to the nearest minute, okay, that will be just, remember here, 0.67 of a minute is not 67 seconds. Okay, that would be a very obvious mistake to make, but one I would see all the time. 0.67 of 60 seconds is about, like 0.75 is 45 seconds. So it's about 42 maybe, okay? So 66 minutes, 42 seconds ish, okay? In fact, I could find out exactly using my calculator, which I have off down here. So 0.67 multiplied by 60 is how many seconds? Oh, 40.2. Now, that's more than half a minute. So basically, we're talking about 66 minutes, okay, 40 seconds. Now, to the nearest minute, that's closer to 67 minutes. And that's my answer. Okay, so look at the notes. That's just trying to put it down there. It's complicated, but this kind of question I would need to read multiple times to actually get what's going on here. Once you figure out the scenario, it's not terribly hard in terms of maths, and you can at least give it a go by dividing something. If you had multiplied, actually, if you just divide 250,000 into 1 million, okay, just those two numbers, you'd most certainly have gotten the 3. It's not correct answer, but it's a correct relevant step. Now, I'm going to clear that off because I need the space for part 2. And it says that due to heavy rainfall, the operators of the dam decide to increase the flow by 10% for 24 hours. Find out how many meters cubed of water were released in that 24-hour period. It then says, give your answer in the form of a by 10 to the power of n, so in scientific notation. Now, all this means is, like if I said, write 10 as a by 10 to the power of n, it'll be 1. Now, it also gives this proviso. A must be between 1 and 10. So in this case, like the number 10, 1 by 10 to the power of 1 is the same thing. 100, okay, is the same thing as 1 by 10 to the power of 2. So my number here, that's a by 10 to the n. The a is between 1 and 10, and it's to the power of 10. So you can convert any number into scientific notation. It's something that it's tricky enough, but it's like any skill. Once you get it, you have it. Now, in increasing the flow to be 10%, I need to know what the flow is for 1 day. Now, to do that, the only information I have about a flow rate is 250,000 liters per second. Now, if I'm increasing that by 10%, okay, I could find out what that is by multiplying that by 10%, okay, and then adding that on to 250,000. Or, what I prefer to do here is, if I multiply that by 110%, okay, now 100 plus 10% is the same thing as 110%. Now, that's the same thing as multiplying by, remember that 100% or 110% is the same thing as 110 over 100, which is the same as 1.1. So multiplying by 250,000 by 1.1. Now, I can use the calculator for that. And I get let's type it right, 250,000. Okay, it's right. Multiply by 1.1, and I get an answer of 275,000. 275,000. Now, that's liters per second. Now, we want it over a 24-hour period. So, in a sense, the 275,000, I need to multiply that by 60 seconds, okay, for how much in every minute, by 60 minutes in every hour, by 24, because 24 hours in a day. Now, that calculation is fairly full on, okay, so I'm going to go to my answer. That's where we are here. The answer to that is this big, huge number here. So 3 is 23, almost 24 million, okay. 3 zeros is 1,000, 3 more digits is a million. So 760,000 liters in a day, okay, liters per day. Now, they don't want that as this number. They want it in scientific notation. So I need to move. My decimal place is always at the end of a number. Okay. I want my number A to be between 10 and 1. So at the moment, I need to move the decimal place once, twice, 3 times, 4, 5, 6, and 1 more, 7. So I end up with 2.376 by 10 to the power of 7. And that would give me the same number. Okay, so basically I'm multiplying this by 10 million. And the decimal place moves 7 times back this way. Okay, and that's what scientific notation really is. Now it says, give the value of A correct to 3 significant figures. Currently there's 4. I only want 3 of those 4. So this last digit has to turn away or go away or turn to 0. Now, at the moment it's 6, so the number prior to it will go up by 1, just like normal rounding rules. And I get 2.38 by 10 to the power 7. And that's, do I need units there? That's liters. Yeah, I probably do need units there. I forgot to add them in. I hope I didn't lose half a mark there. And that's part A, part 1 and 2. Okay. Now, part B, part 1, it's a complete different scenario. It says, John walks around a circular trail of radius 0.5 at a steady speed of 6 km per hour. So if your man starts here, okay, that whole length around would be one circuit. He's done 3 times. So we need to, if we know what the length of one circuit is, we can use that to find out how long it took him. Okay, how many? If he does 6 kilometers in 1 hour, how many 6 kilometers did he do? Okay. Now, the circumference of a circle is given by the formula 2 pi r. That's in the maths tables. It's basically the length around the circle. So we know 2 pi, the radius there is 0.5. Now I can put that through the calculator. I need to actually, I don't want it in terms of pi. So that's 2. Now, the pi button of my calculator is down here on the second function. So press the shift and the pi and multiply that by 0.5 brackets. I get, in terms of pi, and just get rid of that, that's 3.1415, which actually is pi, 3.1415. Now, we want to know how many seconds that we were dealing with, okay? And he did a circumference of, that's one circumference, but he did 3 of them, okay? So that's roughly, I'm going to say 9.42 kilometers. Now, how many kilometers did he walk? 9.42. So we're basically looking for 9.42 divided by 6. How many 6s were there in this? And that will help me find out the number of hours. Okay. Now I'm going to go to the answer here. I'm kind of gone messing a bit. So that's our 3.14 kilometers. Now I've rounded it here. I hope that's okay in the sense that that could achieve a penalty, although I use the marking scheme to make this. So that's what's in the marking scheme, I imagine, or similar to it anyway. So we got the 9.42. Now, time is equal to distance over speed. We can use that formula. And I've kind of said it a bit differently in the last thing, but so it's 9.42 divided by 6, and that gives me 1.5707 hours. Now, they wanted in minutes. So we need to multiply that by 60 to find out how many minutes that is. Now, it's not 1 hour, 57 minutes. 0.57 of an hour is 0.57 of 60, but if the calculator do it for me, and that's 94.24 minutes. And that's going to be closer to 94 than it is to 95. So my time is 94 minutes. And that's that. Okay. Now the next part 2 says, actually I'll go back here. Now this is quite a confusing part. And it says Mary decides to walk every day over a 5-day period. Okay. She walks a distance of 3 km on day 1. Okay, so day 1, she goes 3 km. And then she increases the length of her walk by 15% each day for the next 4 days. So on day 2, she's going to be walking 3 times 1.15. Okay, now that number is going to be 3.45, but that's not necessarily the way it's the best way to go. Day 3 is going to be 3 times 1.15 times 1.15. Okay, because she's increasing it again. Now the reason I'm using 1.15, that's the same thing as 100% plus 15%. Now that's 100% is the full 3K plus the bit extra. So 115% is the same thing as 115 over 100, which is 1.15. The reason the 1 incorporates the 3 kilometers she's already walked, and the 15, the 0.15 rather, is the extra. So the extra in day 2, you're increasing that by 1.15. So day 4, it's going to be 3 by 1.15 by 1.15. So that's day 3 by another 1.15. She's increasing her distance again by 15%. Now day 5, it's going to be 3 by 1.15 by 1.15 by 1.15 by the last day, which is 1.15. Now, if you have these numbers, they're multiplying by each other. That's the same thing as 3 by 1.15 to the power of 4. That's it. Okay. Now they say find how long it takes her to complete her walk on day 4. Okay, so this number, let me clear off some of the stuff here. I'm always running out of space. There's more space in the exam paper. I've tightened it up to fit onto the page here. So that's the distance she travels, even though it doesn't look like it. That's a number. Okay, I don't necessarily have to change that to anything else. And we're dividing that by 4. How many 4s in this number? Now, I'll bring up the calculator here. So we have 3 times 1.15 to the power of 4. Now, just whatever, that's equal to the number 5.24-ish. We're looking for how many 4s in that. So if I divide that number by 4, I'm going to get the answer of 1.31 minutes, hours. Okay. Now I want to convert that to minutes because it says find that close to nearest minute. So it's 1.31 by 60, although I probably should use the actual answer on the page here because if I shorten that, I'll maybe make my answer inaccurate. I'm going to multiply that by 60 minutes in an hour, and that gives me 78.7 minutes. Now, 0.7 that's 0.7 of 60 seconds, which is like, it's going to round up to 79 minutes. That's the nearest minute. And that's it. Now, it's a fairly challenging question. Okay, in the notes here, I have like, it's a little less obvious. Time is equal to distance over speed. We kind of use that in the last thing. We need to know the distance. Okay. Now, you can get that like the way we did, but I'm being a bit cleaner here. You're increasing each time by 1.15, and you're increasing it 4 times, because 4 days. The first day was 3, and then the 4 days of increase. You divide that by 4, because that's the speed we were told, okay, and we get our answer. Multiply that by 60 to get the number of minutes. Job done. Okay, so that's question 10b. Now, question 10b, part 3, and if you remember this is brutal, this question. One day during John's walk, he meets Mary at point P on the trail. Okay, so they meet. He's going anti-clockwise, she's going clockwise. Mary is walking in the opposite direction at a speed of 4 kilometers per hour. So she's going 4 kilometers per hour. He's going 6 kilometers per hour. You never know if these markings could get you some marks. How far will he travel until he meets Mary again? Okay, so he's going to be traveling this pretty fast. It's going to be somewhere. Actually, maybe more like back here. Just trying to guesstimate what it would be. And in a sense, we know that this thing is, if I look back, how many? One circle is 3.14 kilometers. So I'm going to guesstimate my answer is in and around 2K-ish. Okay, if I get a number completely different than that, I need to assess if I've done something wrong. Now we know that the total distance there is 3.14 kilometers. Now, again, this is tricky, but if he's walking 6 kilometers in 1 hour and Mary's walking 4 kilometers in 1 hour, and if they meet here, then in total, I suppose the total time is, the total speed is 6 plus 4. So the speed is equal to 6 kilometers plus 4 kilometers per hour. Okay. Because again, that's the time they're meeting in the middle. John has walked more of it, but the bit that Mary walks is part of what the distance is. Okay. Now, that's 10 kilometers per hour. Okay. Now, time is equal to, distance is equal to speed by time. Okay. Now we know that the distance is 3.14. The speed is 10. I'm just going to say time is t. Now, if I bring the 10 across, it's 3.14 divided by 10 is equal to t. That's the same thing as 0.314. So if you're walking 1 kilometer per hour, you go 0.314 of the distance, 0.314 kilometers. Okay. Now I'm not explaining it very well. Now 6t of the walk belongs to John, and 4t of the walk belongs to Mary. Now, if 6t is John, that's the same as 6 times 0.314, and that gives an answer of, I have the marking scheme here on the next page, that's 6.314 is equal to 1.88495 kilometers. Okay, now they want the answer in meters. Okay, so that's 1.88495 times 1,000 is 1,000 meters in a kilometer. Okay, and it's 1,884.95 meters. And they want it to the nearest meter. 0.95 is closer to the next number. Okay, so it goes up to 1,885, and that's it. Okay, now that's a hard problem. There's multiple ways to approach it. Not sure if I've done the best way. I'm kind of relying on the marking scheme a little bit, and I never actually had to problem solve it. If you're hitting a question like this, that's totally befuddling you. Like I did earlier, if you write, something up there, I wrote the 6K and the 4K, that'll probably get you to 3. If you'd added those two numbers together, you'd probably get to the 5. Okay, and if you don't know anything else to do, add them. Add something, multiply something, just do something. Okay, chances are it'll work out and you get something. And if there's a question you just have no balls, notion what to do, then that's good. It's better than nothing. Now that's the answer there, and that's the end of question 10. And so that's the end of question 10 for the Leave It Cert Ordinary Level Paper 1 from 2021. As always, if you want to copy the notes I'm working off, just send me an email at shanetroy@gmail.com. If you like these videos, hit the subscribe button to get access to more playlists. Okay, thank you.